Did you know that quantum computers could solve problems in seconds that would take today's fastest supercomputers thousands of years? Welcome to the world of quantum computing. Researchers at the University of Science and Technology of China, USTC, announced in December 2020 that Zhuzhang, their photonic quantum computer, completed a challenging computation, namely Gaussian boson sampling, in about 200 seconds, about 3 minutes and 20 seconds. They calculated that the Sunway Taihu light, one of the fastest traditional supercomputers in the world, would need about 2.5 billion years to finish the same operation. With this accomplishment, the second time a quantum computer has shown quantum supremacy or quantum computational advantage, in which case it performs better than a classical computer on a particular job. In 2019, Google's Sycamore processor made the first such claim. In this video, we'll dive into what quantum computing is, how it differs from classical computing, and why it's considered the next frontier in technology. We'll explore how it works, its potential applications, and the challenges it faces today. Whether you're new to the topic or curious about the future, stick around to learn about this game-changing technology. Let's start with the basics. Classical computers, like your laptop or smartphone, use bits to process information. A bit is either a 0 or a 1. Quantum computers, on the other hand, use quantum bits or qubits, which can be 0, 1, or both at the same time, thanks to a property called superposition. Think of a coin. A classical bit is like a coin that's either heads or tails, but a qubit is like a coin spinning in the air, being both heads and tails until it lands. Another key concept is entanglement, where qubits become linked, so the state of one instantly affects the other, no matter how far apart they are. Let's know how quantum computers work. Quantum computers use quantum gates to manipulate qubits, similar to how classical computers use logic gates like AND or NOT. These gates are combined into quantum circuits, which perform computations. Unlike classical computers that process tasks step by step, quantum computers can explore many solutions at once due to superposition. Some famous quantum algorithms include Shor's algorithm, which can factor large numbers super fast, and Grover's algorithm, which speeds up searching unsorted databases. These algorithms are why quantum computers could outperform classical ones for specific problems. What can quantum computers do? They have the potential to revolutionize several fields. Cryptography. Quantum computers could break current encryption methods, like RSA, by factoring large numbers quickly, leading to a need for quantum-safe cryptography. Optimization. They can solve complex logistical problems, like optimizing delivery routes or financial portfolios, faster than classical computers. Drug discovery. Quantum computers can simulate molecular interactions, speeding up the development of new drugs. Materials. Science. They can design new materials with unique properties, like better batteries or superconductors. While quantum computing remains in its nascent stages, the relentless advancements spearheaded by industry leaders such as IBM, Google, Rigetti, and IonQ underscore its transformative potential. Present-day quantum systems, however, grapple with significant hurdles: high error rates, fleeting qubit coherence, and the complexity of scaling qubit counts that limit their practical utility. Despite these challenges, the horizon glimmers with promise. Experts anticipate that within the next decade or two, quantum computers could achieve quantum advantage, outperforming classical counterparts in specialized tasks. As global efforts intensify to refine stability, reduce errors, and scale architectures, the race to unlock this revolutionary technology is accelerating. Though the journey is arduous, the future of quantum computing shines brightly, poised to redefine computation and tackle problems once deemed insurmountable. If you like this video, like, share, and subscribe. Don't forget to comment down your thoughts.